In the last video, we looked at, multi-step equations with variables on both sides. So today we're looking at what we call literal equations. So equations that are with more than one variable in it, and we're solving for a variable. So that doesn't mean we're getting like a numerical solution. Okay, so before we dive into that, let's just review some key concepts of solving multi-step equations. So in number one, I would start with in number one, distributing the 3. And so I get 6x minus 12 is equal to, then I'll distribute the 2, so 4x minus 16, and then we'll bring down the rest of the problem. Then I can't combine like terms on the left-hand side, so I'll just bring down the 6x minus 12. And then I'll combine like terms, and I get 6x, and then I've got negative 16 and 4. Okay, so that gives me negative 12. Hopefully you notice right away, hey, they're the same exact equation on both sides. So when they're the exact same thing, we call this infinite solutions. Infinite solutions. Okay. So in number 2, there is a little negative outside that set of parentheses that I'll go ahead and distribute. So that gives me negative 5x plus 10. From that, bring down the plus 15. And then negative 5x plus 15 on the left. Then I'll go ahead and combine like terms. And so I've got, 10 plus the 15 gives me 25. So there we go, bringing down the rest on the left-hand side. Now I've kind of run out of room. So what I'm going to do is I'm going to continue this down here. So negative 5x plus 15 is equal to negative 5x plus 25. So putting my balance line down the middle, I want to get my variables to one side, and so I'll add 5x. That cancels. Adding 5x, ooh, that cancels. So I'm left with 15 is equal to 25. That doesn't make any sense, right? Like, what? So in this case, we say that we have no solution. No solution, my friends. So let's dive into this whole literal equation thing. So like I said, a literal equation, let me just move this thing up really quick. A literal equation is an equation that consists of, so we're going to say consists of multiple variables. We can even say constants sometimes. So variables, constants, remember, which are just numbers, and operations. But commonly we see just equations that are just all variables. Like in number 1, it says solve d equals rt for t. So when it says solve for t, just think of it as I'm trying to isolate the t. So d is equal to rt. So the only thing that's by t is the r. So if r were a number, I would divide it to both sides, right? And that's exactly what I'm going to do here. So if I divide both sides by r, t is now by itself. And that's equal to d divided by r. That's my answer. That's it. Okay, I know it kind of seems weird. And that's the t. I know you're going to cringe at me saying that. So number 2, hopefully you recognize this equation, y equals mx plus b. That's a linear equation where m is your slope and b is your y-intercept. So in this case, we're just going to look at it as a literal equation where we want to isolate b. So putting my balance line down the middle, I actually want to move the m and the x to the other side. Well, think about when I was getting my variables to one side, I would subtract them, right? So I'm going to do the same thing here. I'm going to subtract mx to both sides. And so I get y subtracting mx is equal to b. Now, I don't like to write it that way, so I'm going to flip it, because if whatever I'm solving for should be written first. So b is equal to y minus mx. That is my answer. Then in number 3, my goal is to solve for x, and now that we're including some numbers. So I'm going to write y equals 2x minus 5. Okay, so drawing my line, my balance line down the middle, the things around the x are the minus 5 and the 2. So just as if I were solving for x, my last couple equations in my last videos, I would add 5 first to both sides. Now I'm adding 5 to a variable, so it's just y plus 5 is equal to 2x. And then finally, to get rid of the 2, I'm going to divide both sides by 2. That cancels. X is now by itself. And so x is equal to this whole thing. I can't simplify that. So it's just y plus 5 divided by 2. There's my answer. I've isolated the x. Now in number 4, we have a fraction. So we have to remember that when we're trying to get rid of fractions, especially when we're multiplying with them, we multiply by the reciprocals, right? So we're solving for b. Everything in between the 1/2, the b, and the h is multiplication. Okay, anytime you see numbers and variables just kind of sitting next to each other, it's all multiplication. So I would first get rid of the 1/2. And remember, to get rid of it, we're going to multiply by its reciprocal, right? So I'm multiplying by the reciprocal, which is really 2 over 1. That goes away. Multiply by 2 over 1, which is just 2. So now I'm left with 2a. Okay? It's usually the most complicated part of this, so I'm going to let that kind of sink in. What did I just do? So that is equal to b and h, and I'm trying to get b by itself, so I got to get rid of the h, and I'll divide both sides by h. So h cancels. I'm going to write b first. B is equal to, and then this whole thing right here, 2a all divided by h. Now for number 5, I'm solving for g, and if you notice, g is kind of like trapped in my numerator because it's all being divided by 3. So I want to break the bond of dividing by 3, and I'm going to multiply both sides by 3. I'm going to start there. So that cancels. I'm left with f plus g is equal to, and then 5 times 3 is 15. And if I'm trying to isolate the g, I'll go ahead and subtract f to both sides. So f is now gone, g is by itself, and g is equal to just 15 minus f. Then number 6, I'm solving for x. X is right here. Now before I can divide by 3, because some of us think, okay, I'm just going to divide by 3, that's the only thing by the x. I actually want to subtract the 2y to both sides. I want to move that guy over. This guy's got to move over here first. So now I'm left with 3x is equal to 4 minus 2y. Now I can divide it by 3 because it's the only thing left over there. So when I divide by 3, that cancels. X is now equal to 4 minus 2y, that whole thing being divided by 3. So maybe try number 7 on your own. Hopefully you're feeling a little confident, willing to try one on your own. So for this one, I equals PRT. It's a simple interest if you were wondering. I will try to isolate, I'm trying to isolate the t, right? The t again. Gosh, I'm so funny. Okay. So I'm going to divide both sides by p and r, and I can actually do this all in like one step. Since it's all being multiplied, I can just divide everything I want at the same time. So I'm going to divide both sides by p and r, so this cancels. I have to do the same thing on the other side, p and r. So t is now by itself, right, over here, is equal to, and then I'm just going to write this whole thing over there. So that's going to be I all over p and r.